I'm gonna give everybody a minute to log in because we just started, so we're gonna hopefully start within like a minute and a half, so 11:02 or something. So all the people who are waiting, just so you know that you can get your water or coffee or tea, and then be back in a minute. I'm glad that everybody can see the text saying that we will start at 11 a.m. sharp, but we're gonna wait 20 more seconds and then we'll start. Well, I guess it's as good as time as any, Jonas. Okay, so I'll start. Okay, thank you everybody who has joined in. My name is Ott Salmar and I'm head of sales at CloudVisor, and we're the host. I will be hosting the webinar today, and obviously the topic, which is scaling to your first 10 million users. We have Jonas Jovaisas here, our customer success manager, delivering the presentation. So Jonas, do you want to say hi to the audience?
Everyone.
And I'm very happy to have him. He's a superstar in our team, knows really a lot about how to build the architecture correctly, has worked on some big client projects and so on. So really happy to have him deliver the speech. And before we start, let me just give you a few words about CloudVisor, and just so who hasn't heard about us before or who has heard so long ago, we'll just refresh your memory. So next slide, please. And here we go. So CloudVisor, we are an advanced tier AWS partner. We're operating mainly in the Baltic and Nordics, although we have clients all over the world. And we focus solely on startups as our clients. So we're very familiar with the ins and outs of how to scale and build, especially the infrastructure part of AWS. So we can help you do all of that very efficiently. And next slide, please. Also, we're an official scout for the AWS Activate program, which means we can help you figure out how is the best way for you to get as much free AWS credits from AWS as you can get. So it can go up to 100,000 US dollars that you can then spend on AWS services. And also it depends on how, old the startup is, how well you're doing, and so on. So it's very individual for each startup, depending on the programs and investors and so on. So I can tell you a bit more about at the end of the webinar. So without taking too much time away from Jonas, then as a last thing from me, I will mention two things. So questions are very welcome. Just submit them in the Q&A section or the chat, and then we'll go through them as we go along. Or if we know that the presentation will cover it, then we won't be addressing each question individually. And since we are recording this event, we'll share the recording with everyone tomorrow. So if you're missing a part or you want to revisit something, then you will have it available for you to access. And that's all from my side. Jonas, you ready to take over?
Yeah, sure. Thanks a lot for a great introduction, and thank you guys for joining us today. Yeah, to make things more interactive, we have prepared a question for you, which will be at the end. And I hope this presentation will help you to get the great answers for it. So 3 lucky ones will win our awesome CloudVisor t-shirts with AWS pedigree. So yeah, that's the good stuff, and more good stuff is waiting for us ahead. So let's start. Yeah, scaling to your first 10 million users. So the title is quite catchy. Yeah, perhaps you're here because of it, but we're going really to talk about this. And as I only have about 20 to 30 minutes to talk on the topic, you might guess that I am going to gloss over many of the architectural designs and the AWS services. So we'll tell you about the main steps that you have to take on this scaling journey. However, how the typical AWS infrastructure should scale under AWS recommendations. So I hope you will find something useful for yourself, for your situation. And let us start with the map and the map of AWS global infrastructure. What I want to tell about this map is that you must use the AWS global infrastructure for your advantage. It has 25 regions all around the world, and it has over 200 edge locations. So you can put your content closer to your users, so they experience less latency and they reach your web applications even faster, and makes them more happy. So use it, use it, use it. Considerations. As you know, each problem has many solutions, and even what I will tell you today is not a single truth that you have to follow. It's just an informational kind of webinar that you would see the possibilities to use other services apart the ones that you know already. So every decision is reversible in the cloud, and take time, test it, build it, and see what fits for you. So the building blocks, they are two types, kinda. The ones that you can build yourself and the ones that AWS has built for you. With the ones that you can build yourself, we call it DIY. And with these, you have to make sure that you make them performant, you make them highly available. You also have to patch it, manage it, back it up, and do all this heavy lifting. And that takes away your time from building your cool web applications. On the other hand, you can use the AWS services that are highly scalable, available, and they're just at your fingertips and just a few clicks away. It takes away most of the managerial stuff that you have to do with the DIY stuff. So as much as you can, please do use the AWS provided services for your applications. They will scale faster, they will be more reliable. And the cloud philosophy, I would call this slide like that. You have to learn about the cloud. You have to know what you can do in it. Then you have to build it and then measure it, monitor it, test it, see if that works for you. And if that doesn't work, or you have scaled past that threshold that this architecture worked, then you have to learn again and build it and test it and measure it and do the cycle over and over again. Don't be afraid to change your architecture. It's not in once you build once and use it forever. It's not like that in the cloud. It's not on premises. So change your architecture as your business grows. And your scaling journey begins with the day one. And let me just congratulate you. Your application will be going to be super popular. And on the day one as the developer, you know that you have to have a web server. So you take that EC2 instance, launch it. You know that you have to have a database, and you launch another instance and put the database into it. You know that you need a public IP address. So you attach an elastic IP address and host your fancy domain in AWS Route 53. And unfortunately, with the great fame comes great responsibilities. And you just have to know how to scale, how to stay ahead of the demand, because if you don't, your users won't be happy. So how to scale? Well, being technical people, what we do when we don't know, we search it. Yeah, we Google it. And here are the results on how to scale on AWS. So the first 5 results, as you see, point to Autoscaling. So we turn that on, take our DevOps hats off, and it's done. Congratulations. Sadly, there's no single magic button that you can press in the cloud. And the scaling is, well, a journey. And with really high volumes comes really interesting decisions you have to make. And that's what we're going to talk about today. The first thing that you might encounter in your scaling journey is that there are many types and sizes of the instances that you have launched already. So how to choose it, how big it must be for your workloads. So let me just give you an analogy of the online shopping. I really like to order like 5 different items with 3 sizes each, and when I receive the package, I open it, I try them all, and perhaps buying 1 or 2 and return the rest. It's the similar thing with the instance resizing. You stop your instance, you change the size, you change the family, and start it up, measure it, monitor it, looking for the improvements that you are seeking. And if that fits, you stay with that. And however, on this scaling, you will eventually hit an endpoint where your increased costs and instance size will have diminishing returns. So let's reiterate on your current architecture, and you have the database instance. Well, let's start from that. And what database options do you have here? Well, you can always DIY as you did already. You can manage it, bag it up, it takes your time away from building your application. Or you can choose from AWS managed database options like Amazon RDS for SQL workloads, or DynamoDB for NoSQL workloads. So even if you already have a database, you can easily move it over to RDS. And there's the question, to NoSQL or to not to NoSQL. Well, I would advise to start with SQL. And advantages are that it's simple to set up, it's very stable, it has been here for decades, and developers are really familiar with the ins and outs of workings of the SQL databases. So it's good for your first million users, so don't worry to start with the SQL, and don't be bothered with that, all the fancy NoSQL things that you hear about all around. So you can move to NoSQL as when it's needed, so don't worry about that yet. Okay, you have your first 100 users. What do? You have that Amazon RDS instance already, and 100 users are churning onto your web application just fine. 1,000. Look at that architectural changes. So you, at this scale, you have to start taking the power of AWS Cloud and utilizing the availability zones that you have. And in this example, you just take your instance, clone it to another availability zone, put an application load balancer in front of it, and then you make highly available not only your instances but also your database instance. You go to the Amazon RDS console, press the make this database multi-AZ, and your standby copy is copied to the another availability zone. Congratulations, your first highly available architecture is built, and requests are balancing, everything looks good, you're good. Let's talk about that scaling once again. So we talked about vertically already, where you just increasing the instance size, changing the types of the family of the instances, and there's a limit to what you can do on that path. So how to scale horizontally? Well, you take the same similar sized instances and put them right next to each other for as long as you want. Actually, you put a load balancer, and load balancer will distribute the traffic required, routes it to the correct instances, and you can actually achieve quite an infinite scale with that. However, on that infinity, don't quote me on that. Okay, 10K users. All right. So you didn't make much changes from the last time, and you just increased your instance fleet. And now you have 8 instances across 2 availability zones. But you start to notice that your database is starting to choke a bit. And what do? Well, you create Amazon RDS read replicas. It's a really simple operation. You just go to the console and launch a few of read replicas. Then you go to your application, point heavy read queries to the Amazon RDS read replicas endpoints, and well, that's it. Your read-related workload from primary database is gone onto the read replicas, and your primary database is just only working with the writes. So you just scaled your database. Let's see what we can do next. Let's put your static content like images and videos and files like installation files, like project files into S3. It's a highly durable and infinite storage AWS service, and put that in front of the CloudFront. And CloudFront is a global content delivery network which utilizes those 218 edge locations all around the world. And it basically creates a network of your content all around the world, and users get to the CloudFront endpoints with the much lower latency. They grab the content from S3 buckets that are cached in the CloudFront, and even the dynamic content that's your instances are serving is also routed through Amazon Global Backbone Network and has lower latencies. So I really urge you, whenever you can, put those static content in the S3, attach the CloudFront, and also attach your load balancer to the CloudFront so you can achieve and leverage that AWS Backbone network. Let's do more stuff with your architecture. And next, I would like to cache some RDS queries. You know that when you open the page always queries the database with the same parameters. So the results are most of the time the same. Well, you can cache those queries, and when the user opens that page, well, the query response will be served from Elasticache nodes, and it will be served in a single-digit milliseconds, and the latency will just drop sharply. Next, oh, look at that, it's a DynamoDB. And as I said, when you are ready, you can move to DynamoDB. And at this point, I would really advise you to find a suitable data that you already have in RDS and start to migrate bit by bit to DynamoDB. And it's highly scalable NoSQL database, and just use it for the stuff that it's built for. So great job. 10K users is no joke, and your web application is now more lightweight. You even resized down your database instances, and you don't even need so big of a fleet of EC2 instances to serve those clients. Thanks to Amazon CloudFront, read replicas, Elasticache, and other improvements that we have made. And well, you might argue that it's not the best time to talk about the autoscaling, but I wanted to spare it for later. Why? Because I wanted to talk to and tell you about the other options that are available for to scale your workloads, not relying entirely on autoscaling, because it's quite an interesting product, as we can see, because it can save you a lot of money with the automatic scaling of your compute power. However, it's not a tool that suits all the scaling challenges that you will encounter. So let's do that. Let's employ that auto-scaling group across the availability zones, so our instances fleet size is not constant, and it also responds to the request that we are receiving. If we have a spike of requests, the instances will scale up, and we'll have not 8, but let's say 10 or 20 or 30, as many as we want. And with a 500,000 users, you as a single developer starting to think that you need more hands. You can get every hand that you can have. So let's use a AWS Systems Manager, which is basically your systems administrator in the cloud. You can task him with common tasks like automate some scripts, like manage remote access without employing security holes in the firewalls, do patching, do compliance reporting and other stuff. It's really cheap and it's really powerful, so make use of it. Okay, so let's automate our infrastructure now. So what does that mean? Well, your infrastructure is not constant. As you saw, it changes all the time. And depending on the workload you have, you might employ certain changes. And AWS CloudFormation is the service that you want to start looking at into if you are not already. What CloudFormation does, it allows you to write your infrastructure as code. And when you need to have changes in that infrastructure, just simply edit the code, redeploy it, and it will automatically track the changes that you need to have. And well, you're done. Other things that we have to consider about the infrastructure automation. As of now, we only work with EC2 instances. They're great, they're fine. However, containers is another buzzword you might have heard. Use containers. They are more portable, they are more lightweight, they are faster to launch. So Amazon offers two services for containers. So it's Amazon ECS for their proprietary container orchestration tools, and Amazon EKS for the Kubernetes open source orchestration services. And then you can move those containers and run those containers on the AWS Fargate. It's a serverless AWS container compute engine where you don't have to worry about the underlying compute power that you need for your containers to run. Because with the ECS and EKS, you can either run your containers on EC2 or on Fargate. So choose what's best for your workloads then. And with 500,000 users, monitoring is becoming really, really important. Start as early as you can and improve it all along the way. And what it does, it helps you to notify some spots that aren't working as expected. Are there anomalies? Are there some events that you want to respond? So use Amazon CloudWatch for that. So as it collects the metrics from the EC2 instances and many other AWS services, it can collect logs, it can monitor, it can act on some events like autoscaling. So use it at your advantage. You can even, as we'll see in a bit, you can use it to launch functions to remediate. For example, here we have a CloudWatch anomaly detection enabled, and we see that this usage spike is right here. So the CloudWatch alarm is issued, and you can, for example, write a Lambda function to increase the fleet size, or to, for example, for autoscaling group to strictly change the desired fleet capacity. So CloudWatch is really important. It's not a tool that fits everyone, but give it a try. What about the architecture of your application? Not about the infrastructure, but application. Well, up until now, I think that it was kind of monolithic. It complies of all the user interfaces, business logics, data access, data layers, and all this fancy stuff. It isn't separated. And when one part breaks, probably others too. So you want to be a bit more agile on this architecture approach. So SOA, and what does that mean? Yeah, well, again, we go to the Google, search for it, and here it is. It's a service-oriented architecture. Okay, but what is it? Well, basically, it means that you can separate business operations to individual services, and then you can operate, manage them, upgrade, scale them independently. And this gives you much more freedom and flexibility to scale some parts of your application and not others which are performant enough. And it offers a great path on your scalability journey. So think about that, because it will be really needed when we will go further along. And serverless. Well, I have talked already about AWS services in the beginning, but this part is about the serverless services. I have also already talked about the Fargate a bit, and about the Lambda, which is just a function that runs, that you write and it runs in the response of events, and the events can be issued by Amazon SNS, or notification service, or SQS, the queue service. And you can then even use API gateway to expose your application's API securely and to the whole world using the CloudFront distribution network. So use serverless, don't build yourself, try them, see if that fits for your workloads. And Amazon did heavy lifting, so you don't have to now. Loose coupling is one of the SOA prerequisites, let's put it that way. What does it? Well, let's see. You have an external source which issues some sort of request. That request is received and pushed to the queue, SQS, and then instances or other compute means of compute like containers or Fargate or Lambdas. Then they get that message from the queue, they process it, then put the answer to the queue, I have done it. And the queue then informs the notification service again that this request was processed, and it will be responded back to the source that all is good, your request was processed, and here's the answer. So this is kind of microservice architecture already, that you have separate logics for separate functions. You have queues separating your microservices. And let's talk a bit more about the Lambda that I touched on just a minute ago. So Lambda, as I said, is a code that you write and run in the cloud. It's serverless. It has as much compute as you need. It can run in many environments, most probably the ones that you are coding into also. And it can react on many different sources they can be invoked from many different sources, like Amazon CloudWatch alerts that I have talked already, and DynamoDB changes or additions, or also Amazon S3, for example, a new file was uploaded, so your AWS Lambda takes that file, resizes it, pushes it back to Amazon S3 in a different folder structure or something. You can get really creative, and there's quite no limit what you can do with those Lambdas. Lambdas are also very convenient for your infrastructure remediation actions. For example, you spot something with the alert and write code to respond that alert, so that alert would be solved. And your microservices architecture kind of looks like this now, and you see, well, it should have been more scalable and easier to manage, and look at this mess. Well, there are some ways to make sense in that chaos, and AWS Xray is a visibility tool that AWS built just for these such of cases where your architecture is growing rapidly and you're starting to lose sense of what it does and what are the components for. And it even builds a map of your requests where you can see which parts of microservices are more performant or have a bottlenecks, and take the action on those ones. And well, you can see where are we going, the 1 million. Yeah, use all of that, and you'll hit 1 million. So to quickly reiterate, what we have done is we took the multi-AZ approach. We put an elastic load balancers, and we have also enabled auto-scaling and service-oriented architecture approach. And well, look at that. It's a 1 million user architecture. So there are a couple minute changes that you can see here. So there are like a worker nodes, different independent scaling group, which works on SQS queue, There's Lambdas that are responding to DynamoDB queries. There's also CloudFront, which serves the API gateway, and the API gateway messages are also processed by AWS Lambda and put in the DynamoDB table. We're employing CloudWatch and SES for emails. So yeah, we're doing great. We have scaled our infrastructure quite a bit now. And the next point is 5 millions or 5 millions, 10 millions. What do we do then? Well, the first thing that you can possibly guess is going to be database issues. And why is that? You remember I talked about the RDS being really good for, or SQL being really good for up to 1 million users, no worries. Well, in this scale, you try to have looking at some bottlenecks, even at big sizes and many read replicas. So the possible solutions are not very easy concepts to explain in a minute, but I'll try. A federation is like splitting functions of your databases to different databases. For example, you have one database and split it into 3. One will be for users, another will be for transactions, and third will be for inventory, let's say, related data. And then they are combined together with the queries, and they provide better scalability on this approach. Or sharding, where sharding means that you have one database and split them, for example, into 3, and you have that first database for indexing, and the indexing is simply follows which part of the data is on which database. So, for example, you have record A in the first database, record B in the second database, record C in the first database, and so on. So it's just a point of entry to simply just reroute the request to the correct database, and then you can basically scale that horizontally as well. And the third option would be to move some functionality to NoSQL databases, as we talked already. Move even more. That's the short advice. And a quick review what we have done here. So we took the multi-AZ approach. We used serverless self-scaling services, which help us to scale effortlessly, basically. We have built in redundancy and started with SQL, then move it to NoSQL. We cached data and outside and inside with Elasticache, and we used automation with our infrastructure. Also, we have good monitoring, robust monitoring that we rely on. We have split tiers of our microservices. We split our monolithic to microservices and use autoscaling. And another perhaps advice: don't reinvent the wheel as much as you can. Use the services that AWS has provided, so it will be much easier for you. And so I think that's that. And the next steps that you can take is read the exemplary AWS documentation on all the things and more that I have told here. Take a look at well-architected section. It really shines in the breadth that you can, the improvements that you can make to your architecture. Take solutions that are already pre-built, search for them and employ them in the CloudFormation scripts. Use some quick starts on the different parts and or industries that have certain requirements, so you can quick start your journey into AWS with those templates. Okay, and here we are, time for your answers. But what's the question? Well, the question is this: please name 3 serverless applications of AWS. And the first 3 who will answer in the Q&A or chat box will receive our amazing CloudVisor
T-shirts. Yeah. And since Yeva shared her own link to many who are participating, we don't actually have that many Yevas. So if you write your answer, then also write your name so we know who you are under Yeva's name.
Okay, so write your name and the 3 serverless AWS services. Okay, get quick. We're waiting for your answers. And we'll see who will. Yeah, the music. Yeah, I see in the.
Oh, okay. Some went to the Q&A.
Yeah, in the Q&A. Okay, I think Roman is the first answer, I guess.
Yeah, and then Bipin was the second.
Bipin the second. Good.
We have room for one more T-shirt to give out.
Type faster. Guys, also don't be afraid to just tell us what you think about the webinar. Did you like that?
Yeah, and after the questions, if you answer them, then also you can ask questions about. I saw one question was about the recording, so we will make it available later to watch. So if there's any questions for Jonas, as it would be free help right now, so you can use the option or the chance that we are all together, and maybe some other people will also find the answer relevant to them.
Yeah, use the raise hand function in your participant section, so we can see that you want to speak, and we'll let you do that.
All right.
Or
so we
if you're
got
a bit shy, please write it down.
Yeah, we got our three answers, or 3 people, Ridas, Roman, and Bipin. So you were the first 3 ones, and maybe Jonas, you can share the answer with us now as well. Like, what's the right answer?
I can really just perhaps get back to the one of the slides where we have covered a part of the AWS serverless services. They're not all here by any means, but they are probably most used and most useful services here. So, for example, as I said, an API gateway, SNS for notification, SQS for queues, Fargate for container compute, Lambda for functions. Step functions is just a service that allows you to incorporate thousands of AWS Lambdas into some sort of logic that what should do what. And SageMaker for machine learning. So it's really, really powerful service. Also, SES for marketing emails, for huge email campaigns. So these are just only a few services that are available as a serverless options.
Very cool. Very cool.
Okay, so
we have our 3. Yeah, we have our 3. Thank you very much, Jonas, for the great presentation.
Welcome.
And yeah, if you have any questions, just write them right now, or if you don't, then I will pay my debt, as I promised, to talk a bit about the credits in the last part of this session. So we are well under the time limit of 1 hour, and I will only need a few minutes to talk about this. So if you can put the slide up. Okay, you already did. Good. So main thing is that if you are a startup, you can receive up to $100,000 worth in AWS credits. If you have received some already, then that's great. That means that you are in the right mix and can grow from there. Obviously, it is attached to the milestone you achieve a little bit in terms of how fast you grow, what incubators or programs or VC funds you have that you work with, and so on. So if you have any specific questions around that and how to maximize the credits more efficiently if they're about to expire, we can help with that part as well. So you see my email down there. You can get in touch with me directly, or you can check out our cloudwiser.eu/for startups page. So yeah, that's about that. And the last thing we wrote down, I wrote down the winners of the t-shirts, obviously. Okay, there we go. One question from Yeva, but probably not Yeva. So Jonas, do you see the question?
Yeah, when you divide the database into primary and secondary replica as per the availability zones, how that behave in terms of write versus read responsibility? What would that be in master slave architecture by default? If you're talking about the multi-AZ, let me just bring up the slide for us all to just take a look on it. Where is it? Here is it. So if you're talking about this setup, if I understood correctly, so multi-AZ, oh, no, you're talking about the read replica. So let me just get that one. So if you are creating read replicas and you have your primary database, then simply you have to edit your application accordingly so that read operations, read queries are routed to the read replica endpoints. There will be DNS endpoints of read replicas, and the other operations that include writes would point to that last endpoint of that primary database. So in essence, you should separate the read-related workloads and write-related workloads in your application and route accordingly to the read replicas or your primary databases. I hope I have answered your question.
There was another one as well. When is the right time to move infrastructure into Kubernetes?
Well, I guess the right time is when you are already in the microservices stage. That's a must, I guess. Well, you can also move it a bit earlier. And in that case, you would just simply change your instances to the containers running on Fargate or running on those same EC2 instances. So it's basically the thing that you want to achieve. The containers really improve the portability, the scalability, and perhaps even less management is needed because the environment that container creates is always the same.
And one more from another Yeva. How does AWS compare with DigitalOcean, PostgreSQL, Node, SPA, the web application?
PostgreSQL, Node, SPA, web application. I'm not sure I know what is SPA web application is in a DigitalOcean, but in PostgreSQL, there's, well, Amazon RDS offers PostgreSQL compatible databases. So you can choose Amazon RDS PostgreSQL engine, or you can use Amazon RDS Aurora with PostgreSQL compatible. And I haven't talked about Aurora, but Aurora is just another level of Amazon RDS. It's much, much better, and it can scale globally very fast.
All right.
And Node, perhaps a Node is an instance, I guess.
Okay, cool. I'm not sure I'm using it correctly. Yeah, I'm not all. Okay, so I'll write it into this chat box as well again, because I'm sure, okay, now I got it right. That Pipin and Roman who got the t-shirts for your quick answers, just write to us to events@cloudvisor.eu, so we will be able to send the t-shirts out to you. And I sent the same message directly to Ridas already, so you should have it. But events@cloudvisor.eu, just send us your countries and where you want us to send it, so we'll send it over. And then you can be with the cool t-shirts like me and Jonas are today.
Be the cool guys.
Yeah, okay.
So yeah, thanks.
Yeah, thank you everybody who attended. I hope it was well worth your time. Obviously we can dive into each company directly and talk about specific needs. So feel free to reach out to us through our website or my email at cloudvisor.eu, or you can find us on LinkedIn, everywhere. Basically, we're there. And yeah. So if not before, then maybe see you at the next webinar. And Joras, thank you again for this amazing presentation. So I guess it's a wrap.
Yeah, and I see somebody just corrected me that using containers right time is yesterday.
There you go.
So do that. Great, thank you guys. I hope it was informative. You can use some of those concepts in your own environments, and happy scaling and be awesome.
Yeah, there you go. All right, guys.
Guys, have a good one. Goodbye.
Now is the time, okay, to close everything. All right, there we go.